In this problem, we're asked to find the equation of the plane. So equation of plane, an equation we might argue, that contains 3 points, A, 1, 3, negative 1, B, 1, 1, 1, and C, 2, negative 2, 3. Okay, so what are the theoretical remarks that we could make here? What is it that we need to know? What we need to know is that if you have a plane and you happen to know a point in the plane, let's say the point is x naught, y naught, z naught, and you also know a normal vector, that means it's perpendicular to the plane. So let's say that this is ABC. Then the equation of the plane is A times x minus x naught plus B times y minus y naught plus C times z minus z naught is equal to 0. Okay, that's what we need to know. Now, how do we apply this in this particular case? Well, when you have 3 points, let's try to draw them. So let's say you have A, B, and C. Then by taking the vectors A, B, A, C, you can take any two vectors as long as one is not a scalar multiple of the other, in this case, opposite of the other. Then AB cross AC is perpendicular, meaning normal, to given plane. When I say given plane, I mean the one that contains the points ABC. Okay, so then we can apply the theoretical fact that I just put in red by using any of the 3 points and the vector that we find. So let's find that vector. To find the vector AB, we need to subtract the coordinates of the point A from the coordinates of the point B. So we subtract 1 from 1, that's 0. 3 from 1, that's negative 2. And negative 1 from 1, that's 2. And we cross it with the vector that we find by subtracting the coordinates of the point A from the coordinates of the point C. So 1 from 2, that's going to give us 1. 3 from negative 2, that is going to give us negative 5. And negative 1 from 3, that is going to give us 4. So let's take the cross product now. So this will be I, J, K, 0, negative 2, 2, 1, negative 5, 4. So let's take this cross product. So delete first row, first column. What do you get? You get minus 8 minus negative 10. So minus 8 plus 10, also known as 2. And then delete the first row and the middle column. And that will give you 0, minus 2. So it's minus 2, but since it's the middle one, it's going to be simply 2. And then delete the first row and the last column, and the determinant that you get is also 2. So the vector 2, 2, 2, in other words, is a normal vector to this plane. And we can apply this formula here with the point A, 1, 3, negative 1, and this will give us 2 times x minus 1 plus 3 times y minus 3 plus 2 times, I'm sorry, 2 times here, plus 2 times z plus 1 is equal to 0. There's no particular reason to simplify this. We can leave this as it is, and that's the equation of the plane we were looking